Hi guys, this is Chandra. Welcome back to our channel from the Department of Information Science of Engineering at 6th semester from the College of Engineering, Venkateshwara College of Engineering at Bangalore. Today we are discussing the subject called as a non-conventional energy. And the contents we are going to discuss right now is the flat plate collector and the working principle and the applications and the merits and demerits. Some common uses of flat plate collector are like a space heating and the heating the summer pools or the hot tubs and the support of an house holding solar water heating in the heating system and the preheating of a fluid in the industrial sector. And the one is this how the look the flat plate collector and the solar radiations like which is falling on the glazing, and there's a observable plate which is located over here, and that is the inflow, there's outflow, and this is the insulation, there's the angle between those things. And this is a working principle, and due to the environmental crisis of an growing demand of an energy, and the development and the implementation of a renewable energy has become a matter of a great importance. The solar energy is a promising source of energy due to its free availability and the low operating cost, and along it's a being a non-polluting source. The solar energy can be used in the solar water heating system and also the polar heaters and the other heating system. Within the solar energy system, the main components in the solar collector, and which is a heat exchanger that absorbs and captures incident solar radiation, converting into the heat and then transferring in the heat to the fluid, like usually the water and the air, and that flows through the collector. All the solar flat plate collectors produce a lower temperature. They have the advantages of being simpler in designing and having lower maintenance cost, and those are the most used collector for the solar heating system in the residential and the industrial sector. A typical flat plate collector consists of an insulated metal box with a glass or the plastic cover and a darker colored absorb plate. According to the Matt Reeve and the Frax in 1997, the configuration of the solar collector as an important often determines its thermal performance. A solar collector with a serpentina tubes works better than the conventional collector with the parallel tubes due to its earlier appearance of the turbulate turbulent flow that improves the application of an air transfer and the increase its maximum efficiency from 62% to 65%. And then Myrna and the Beckman in 1998 they concluded that the internal heat transfer coefficient, and which increased the approximately 3% when the Serpentina flat plate collector was used, and that was the main reason for the performance difference between the conventional flat plate collector and the Serpentina flat plate collector. Eisenman, Weiss, and Virginia Ackerman in 2000 they conducted experiment on two serpentine flat plate collector, and which had the same shape of geometry, and in which the first collector the serpentine tube was welded directly to the absorber plate, and Wilsted is in the second collector where the serpentine tube and the flat plate were joined within the thermal fusion. Both collectors were placed under the sun in the identical weather condition, and their performance were compared. And the efficiency of the first collector increased from the 2% to 2.5%. And investigation by Prakash and Vishnu Prasad and Ramana in 2013, and Madhukeshwar and Prakash in 2012 showed that the use of special surface coating improves the optical properties of a collector and the operating temperature and the performance of a system. And Sopian and Sayari and Abdullah and Hothman and Yatim in 2004 experimentally studied the performance of a new design of a solar water heater where the collector and the storage tank were integrated into the same unit. Ambient temperature of 31 degrees Celsius, and the temperature registered registered in the storage tank oscillated between 60 and 63 degrees Celsius with a radiation of 700 watts meter square, and the efficiency of system was 45% with the ambient temperature of 31 degrees Celsius. And Prasad Parakoda and Ganvati in 2010 and conducted an experimental study on the water heater with a flat plate collector and the solar tracking mechanism, increasing the system thermal efficiency by 21% approximately. And the meanwhile, the Basavanna and the Shishishekar in 2013 analyzed a flat plate solar collector with a triangular pipes obtaining and increase in the water outflow and temperature up to 330 Kelvin, where Shelke and Patil 2015 analyzed the effort of an variation tube shapes for the flat plate solar water heater and compare the outlet temperature between the elliptical tube and the circular tube, and concluding the elliptical tube gives the maximum outlet temperature of the water for the same heat flux and inlet temperature. The outlet temperature differences between the circular and the elliptical tube was 4.7 degrees Celsius. Simulated and analyzed the flat plate solar collector using the computational fluid dynamics CFD and software. An experimental model was built and experimental test was valid for the CFD model, obtaining good results. The simulated temperature curve has the same behavior as the experimental one and they are similar. A numerical and experimental investigation of the flow and temperature and the distribution in the solar collector and was performed by the Ranjita and Somshekar and Jamuna in 2013. They investigated the fluency of the tube shape and the absorber plate effect on flow and thermal distribution with the CFD simulations. The comparison between the CFD and simulation and the experimental measure shown of only a 5% deviation. Analyze the performance of a flat plate solar collector using a and SY fluent and the investigation of an effect of certain importance parameters such as the mass flow and the material of the observer flat plate variations and the shapes of an collector tubes by comparing the inflow and the outflow temperature of the fluid. Meanwhile, as also using the ANSY fluent and the Mukesh 2016, the compare the CFT solution of a different used from the used forms from the observer plate in the flat plate collector and the plate with the best results was selected to the manufacturer. They concluded that the CFT analysis is an effort tool for the researchers to simulate several models and the different operating conditions without the manufacturing them, comparing the results and saving time and money. As already this slide already I told you, and the advantages come to the advantages at the absorbed directly and the diffused and the reflected components of solar radiation are the fixed in tilt and the orientation, and those there is no need of tracking the sun and are easy to make and or low in cost. A comparatively a low maintenance cost and the long life. Operate at the comparatively high efficiency and the absorber plate. It should have the high thermal conductivity and add accumulator tensile and the comparative strength. Accurate and a good corrosion resistance, and the copper is generally performed, and other materials are all like aluminium, steel and the various thermoplastics. Thank you.